Welcome to Towle Talks. Today we're going to start talking. So again, this is designed for a Programming2 course, so I'm going to go fairly quickly through arrays because I expect you to have a good understanding of the arrays. But we're going to talk about basic arrays in Java, shallow and deep copy, what's the difference between the two, and we'll talk a little bit about resizing the array. Alright, so here we have a basic program. Again, if I'm going too fast, please pause it and copy it on the program or take notes, whatever you need to do. That's the whole point of the video. All I've done is make a basic project called arrays, and here we have the function main. Now, this is how I define an array in Java. I have the type with open and closed square brackets. For those of you who are used to C, C++, you would usually have a star here. And then you have the name, the value for the array name. That's going to be the variable name. And then new, the same type again. It's important we have the same type. I'll show you why in a moment. And then we have bracket, size, close bracket. Now this line, the initialization line, and any line you have when you reallocate the space is the only time the size is going to go inside the square brackets. Otherwise, just like C++, the max index is going to equal size minus 1. Because remember, the index starts at 0. So here's an example of declaring the array. Int array myArray equals new int 50. So this now has 50 spots I can store the array. Here I'll populate the array. Here's a demonstration of how to assign to the array. So for I is 0 to I is less than 50. Remember, the 50 is not a valid index here, even though I put 50 here. This is the size. This will be the index used to reference the array. So my array time I will equal 2 times whatever the I is. So 0 will be 0, 1 will be 2, 2 will be 4, etc., etc. So here's an example assignment. Now if I want to use the array, I can then do, like for example, here I have a system.out.println, array indexed at 3 plus the value 2 is, and then here I have to actually put this in parentheses or tell Java to do a integer add first, otherwise we'll just concat them to strings. So here we have my array 3. So here I'm getting the value. Here I was assigning the value. Here I'm getting the value, and then I'm adding the value 2 to it. So I run this. The array indexed at 3 plus the value 2 is 8. So if we think about this algorithm, at index 3 it would be equal to 6, plus 2 is 8, so that is what we would expect to see. And here is, again, a quick introduction to how to use arrays in Java. So now we have a problem, or we might have a problem. Let's say I have my array from before. This is my array from previous example. Let's say I have very important information in here that I cannot lose, but I want to manipulate it. So we might be tempted to do the following code. We declare a new array, but we don't assign any value to it, or we could assign memory to it either way. We say my second array then equals my array to make a copy of it, or intending to make a copy of it, and then we change my second array, the first index, to 30. But remember, we want to keep the initial data. So if this works the way we think it should, then my array 1 should still be 2, and only my second array 1 should be 30. But if I run this, you'll see that in fact my array has changed. The reason this has changed is this is a shallow copy. My first array is now pointing, or my second array is pointing at the same memory location as my first. Therefore, any value I change in my second array is actually going to modify my first. What we actually want to do is what's called a deep copy. And we will have to allocate space for our second array. Here I've allocated the same amount of space. And then we're going to literally have to go through each individual index and copy the value from the first array to the second array at that index. Notice this little light bulb here. Java has a function called system.arraycopy that you can use, and essentially does the same thing as what this code is. I'm just showing you what the code is. Now, once I change my second array to the index 1 to 30, the original array should remain the same, which should be 2, because I have a different memory address for my second array than I do the first array. So I run this now, and there you see it works. It should be 2, and it is in fact 2. So here with this method, the original array does not change. It's also important to note that if you pass arrays in as parameters, it's passed in as a shallow copy. So anything you change inside a method, any array you change inside a method, will change the array that was sent in. So now it brings us to the last part of arrays I'm going to talk about. We'll talk about this when we get back to data structures. But what if I want to resize this array? So here I made the array of 50, and now suddenly I realize, crap, I need it to be 51. If, and I'll just let you guys take my word for it, if you can try it yourself, if I do this, this will wipe out all of my information. And maybe it's not something like, maybe it's something depending on what the user enters, so maybe you just do not know what this number is actually going to be. So now I need to dynamically resize this array, and I cannot simply redeclare it because I will lose the information I have in the array. So what we're actually going to do is we're going to use the deep copy code that we talked about. I'm going to declare a new array, and this time I'm going to give it the new size I want. Then I will do the initial copy, the deep copy like I did before. And then this time I will change the index or I'll add the value to the index I want. So here we'll say, I don't know, -10. And then what we will do is we will do a shallow copy after this. So here's a situation where you do want to do a shallow copy. This is, remember, I want this array to be resized, not a new array. So here I will do a shallow copy. And unlike C++, you're probably thinking, oh, there would be a memory leak here. There is not going to be a memory leak here because as soon as I do this shallow copy, the spot that my array was pointing to isn't going to be deleted by Java. So originally I declared my array as 50, so the max index would be 49. If I've done this correctly, there should now be an index 50, so I'm going to try to print 50 here. So if I have not actually done if this did not increase my array size, this will throw me an exception. Otherwise, I should see -10. Again, I've made a new array with new memory, I've done a deep copy, and then I've pointed the old array at the new array. So I run it, and then here you say -10. The other minus is from my print here. So that's going to be a quick conclusion with arrays. Again, we'll revisit this later when we deal with array resizing with data structures. One problem is a little more tricky is if I have to insert a value. So say I want to insert a value at the beginning. Well, in that case, I have to change this here. Like this would be my second array I plus 1 equals my array I, and then I'd have to say my second array is 0 and give a value at the beginning. So there's a couple little things I have to change here depending on where I'm adding the data. But it's still going to essentially be a new array, a deep copy, add the new data, or possibly add the new data inside, and then do a shallow copy from the old array equals the new array. And again, you don't have to, if this was C++, you would have to do this, but we don't have to do that now because it's not C++. Thank you for watching this video. I hope you learned something and enjoyed it. If you did, please leave a comment or a like below. And again, thank you.